So friends, we are in second week, and this is the last lecture of our fifth lecture of second week, and I am slightly moving towards showing you application of ANN, how training occurs, and how it is fed to the ANN, what are the activities that are done, and how the output is generated, and of course what is the as a nutshell ANN configuration that we develop for addressing a problem. So if I am choosing a problem of data driven approach, so let us understand one more attempt. I would say the data driven approach, it works in four major steps. I will call 1, 2, 3, 4. In practical implementation stage, So first is pre-prognostic prediction stage. So this is a stage where we have the vision, some prediction is required for the given problem in our head, and for that we have to have the data, information and model conceptualization. You see, three activities are happening together. That means here the domain expert is also involved. We are building the data and information, and then we are having a perpetual interaction how to create a concept, what we are going to do with the data, with the ANN model, with the output, with the testing. So this is a very intense stage actually, and quite a bit it depends on how our results will come out, how well we formulate our problem, data, methods, and its a solution. And sometimes you have to use statistical approaches also. So it goes beyond our feature extraction and all that. So we have to prepare for those things, because software should be available. There should be benchmark software. If we use any software just like that, it may not give the required results. So this is where, and then again the domain experts are involved, and then what is done actually is data elicitation. That means how to present the data in a manner that it is not computationally intensive, it lacks generalization. So some trial and error can be done at this point of time in a primitive way, and the domain experts, because they will be able to tell whether the results is near solution or a solution or out of this basket actually. So and then they can only give some solution point which are available in the plant, and or to add the parameter or to remove the parameter or to change the dimensionality of the problem, so that overall problem is solvable. Then the second stage arises. Once we have done with the intimate information modeling and all that, we come into the characterized normal and deviation and degradation. So again, it's not that domain experts are not involved. Development of a trend vector, what vector will be applicable for what solution. So vector 1, solution 1, vector 2, characterization 2, vector 3, characterization 3, like that vectors are formed. This I am talking about the supervised learning. Then pre-processing. If the data is the vibration data I am using, and if the data is not pre-processed, it will be data intensive and solution may not be available. So some statistical or probabilistic approaches have to be used to analyze the data. And next is feature, like suppose some data is available with the noise. So noise reduction has to be there. So there is some Campbell theorem wherein square of the pulse height, let us say whatever parameter, if we do, the noise, which is a small element, will reduce further, and the principal element will become further larger. So noise, relative size of the noise will be much smaller. If we do 2-3 processing, it will come to almost negligible, and then our principal parameter will be projected. Feature extraction, whether it should be, so if it is a vibration data, what kind of features we want, mean value, variance value, then kurtosis value, then if you depends whether we are dealing in time domain or frequency domain, accordingly data will be, features will be selected or built. Then training, this is a third stage. So now that means data is there, model is there, now training is starting, modeling, AI ML, PCA, principal component analysis, any one of the method, training goes on, and then output presentation. So in our objective is PHM's remaining useful life with uncertainty. Okay. So and then this we have training and all we have done for each vector and all. Now we do some unknown data. We take unknown data, because if we have a data in our basket, 80% data is used for training, and randomly 20% vectors are taken out, and they are used to perform recall test. Recall test means unseen pattern. That will validate our pattern that it can work in area where it has not been trained actually. And on the data, so that will be having a generalization type of index, a higher index for our work that we are doing. So now, since we are talking about the NN problem, again I'll mention this is a consideration from the human body. Okay, how things work at the level of mind. You can see this network, they are connected, and let us assume this point, nucleus, as a point which is called neuron, and how we represent neuron here, and different connections, and then what neuron has a nucleus here, then dendrites, axons means connection, axons means connection. So these are the connections, and synapses, between two neurons the connection will be there, and here also we have between two neurons layers we have connection here, and finally output is generated, and in the frontal area we make the decision. So this was a inspiration part, and this is how in mathematics we build our AI, we build our input. 3 inputs are coming, and they are processed at the node, and output is generated. And here we have summation of all the inputs, then operating it on a sigmoid function. Just one example I give, and the output is generated. And once we have information on the node, so input, output is generated. And this is a 3-layer neural network, layer 1, layer 2, layer 3. It was just for the sake of continuity. So if I have to represent my ANN, this is O, and there is some bias sort of thing, constant term which is there. Plus it operates on input, modification of input, and that's how input outputs are connected. This is a mathematical representation. O represents output at node, which is a function of input x1, x2, xn and all that. It's a mathematical representation. So now probably you would have understood how ANN functions. As I said, feature extraction. For a problem, what are the features you might think required? If I have all the data and I feed all the data, it becomes too bulky. But suppose I want to understand the characteristic of the population, I'll first go for let us say mean. What is the mean of the population? So that will be one node, mean of the population 1 by n, addition from 1 to n, and then crest factor, what is its height. So we get maximum and RMS value, and we have this equation for this. Here how a peak goes up, maximum of x, so kurtosis value. So kurtosis value evaluated by individual point minus average, that is we have, and divided by sigma. It tells about the spread of this data, and we get the kurtosis value. So in vibration, kurtosis values are used, mean values are used. Root mean square, this is one feature which defines our population, is an impulse factor. Okay, the feature is impulse factor, and then finally skewness of the curve. Normal distribution is there, and if the curve is we have a normal distribution, it is a distribution bell shaped, it is spread out on both the sides. But suppose if a distribution like log normal distribution, it comes to like this and it goes, so it is skewed towards this side. So this will find out the skewness of the model data that we have characterization. Okay. So, what we are discussing in this slide is the data should be used to what kind of characteristic are there, what is the mean of the data, what is the peak value of a parameter, if it is a frequency domain signature, which frequency dominates, if it is a time domain signature, at which time it happens, how frequently it happens. So, in vibration, time domain and frequency domain, they are depending on the situation, these data are used. Now, let us say I have built a neural network. How at the end of the day it will look like? Of course, I have got online data coming from the pump motor set. Let us say I want to, based on the vibration, I want to characterize different failures. Okay. So, for me, data has come, we have seen data acquisition system, data has come, the sensors were put on this, and this is a data acquisition processing. So, pre-processing we have done. Pre-processing means along with the data, so many unwanted things comes, like noise, as I said. If noise is there, you have to remove the noise for a better clarity or better result of the data. Okay. If some data were missing, some sensor signals were missing, we have to see why they were missing. And in the absence of those missing signals, can my ANN predict? It should do it actually. So, we should be training it for the certain things. So, this is called data processing. Then feature extraction. In the previous slide you saw what are the features that you have determined that you need to extract from the data, and now your big data space has become into some, let us say, couple of 10 points where all the features are fed to the neural network x1 to xn. And now since you had a feature, you had an output, like suppose if see two peaks are happening frequency domain close to each other by a certain distance or certain separation, then it will be condition number 1. If they are having a different other location, then it is condition number 2. So, condition number n. So, input vectors and condition, which conditions are there. So, what is happening here? We had input data, we had output characterization also. So, we are using the supervised learning methods over here. Now, we train the program, and okay, and we are feeding them this signature also for reference, you know. So, training algorithm goes on and operates in a closed loop, and once the network is trained, it can be tested by giving a sample of data, which is called recall test. Okay. So since we have made the feature and all that, so different data will be fed, and the new results will be seen. They will not be from 1 to n, it will be something else, you know. So, it is quite possible that one of the vector was represented with in the new data, and it is coming close to that actually. So, if it is matching, then NN will say that with root mean square error, this particular vector number x has been identified, and you can judge whether it is correct or not. So, this is how training happens, and then it is in closed loop, and this is how the recall tests are performed. And finally, a neural network is built. And how you will say what is the specification of your neural network that you have built? Number of neurons in input layer 10, number of neurons in the output layer 1, if you can manage with the 1 only. Number of hidden layers is 1. Number of nodes in the hidden layer 15. Okay. Learning rate, system assigned dynamics, momentum rate, because earlier we used to do when we run a neural network, but now system automatically looking at the data, it can work out the learning rate and momentum coefficient. If things are not happening in auto mode, it will keep on changing the learning rate, and it will find out the optimum value. And for same thing happen for momentum rate. So nowadays this because of computational efficiency is increasing, these things can be done online also, or system itself does it. Okay. Only you have to remember is that there should not be over training, or there should not be momentum, should not be very, as I said in one slide, should not be very small or very big. So if it is a very small, then it will take time for training. If it is very big, it will get stuck up into the local minima during convergence. target average error. So this was our target average error, and at each node it was 0.0. So RMS error is calculated in each iteration, and till these iterations are achieved, the training will not be complete. And average RMS error also for this 0.001. Then maximum number of iteration it took 1000, and time for convergence training is 3 minutes. This present modern computers are very efficient in 3 minutes. Otherwise, in 90s or so, it used to take almost 8 hours to train the neural network. It is my experience, I am telling you. But one good thing was there, in those days neural networks are trained, they are behaving the way a human will behave, in the sense that the judgment will be matching with the results actually. So that is how it used to be, and then it is open for flexibility also. So if a new pattern comes which was not part of the training, that pattern if you bring in, the neural network will ask you, you want to train it, this new pattern, you train it, and next time if it is same thing repeating, it will be identifying. So it was like, open for learning. So biggest advantage of ANN is memory, learning, and mimicking the human behavior. The RMS error is model is there. It is given in my publication also, but it is very old publication. So this is what it is. P is number of patterns in the training set. L is the number of layers. D is desired output, and A is actual output. So output, we had desired output node, actual output is X output. Actually X should be input actually, because we are calling input actually. At a final node, these are two actually. Desired output is something that we know, and actual output is going on in the iteration at the output node. Yes. The feed forward and back propagation network, the strategy we have used here is back propagation neural network. Feed forward, back propagation. It goes in the forward direction, see the error, again comes back, and then modify the weight. So modification of weights is the continuous process, and which stops only when the maturity, that is the desired output and actual output, they are matching, and then the acceptable quantitative criteria is at the node it is 0.0001, and at the layer, that is O1 to ON. So that is it should be 001. So this is an actual example. I am not giving the specific data for reasons. Okay. Again, it is a generalization of the some implementation. So okay, we are trying to visualize how RUL data driven approach will be used here. So let us say there is a strainer which is choking, and that is indicated by increase in delta P. So increase in delta pressure, okay, not drop, delta pressure. So that means the pressure on the downstream side will drop compared to the upstream side. So, and that we have in the plant lot of records, okay, and that is, those records are used for training. Each data set becomes the record, and the end of the life is based on some critical value, because it is the plant, it is a management function which will decide when you will call it as a failed. Okay. So if you, the moment you say delta P is equal to 100 mm is the thing when we say it is failed. So that means if I get something lesser than this over here, then I will say, then I translate through ANN in terms of time, and because there were so many curves, these are the two curves I have said, 5% and 95%, in between there are many curves, and correlation of this thing, they will tell us again output uncertainty. We said that RUL should be predicted with the uncertainty. So at every stage RUL is being predicted at uncertainty, and here it will tell, okay, you are certain time signature away from the failure criteria. Okay. And so that means time available is this much. ANNs are trained and remaining useful lives are predicted. Otherwise, why we are doing this? Why this trend? So many trends are using. Sometimes the delta P is a function of simple filtration. Okay. Sometimes it depends on weather condition. Sometimes the job would have gone or some additional source of dust was there in the plant. So all these vectors we have to build to give the correct output. Okay. So it can be decided what management action are required. There is one very beautiful method, principal component analysis. Again, this is we are using again two features. Feature number 1, feature number 2, data points. So we have PC2 and PC1. So let us understand what is PCA. Principal component analysis in machine learning deals with essentially dimensionality reduction. How you can reduce the dimension in a population. So how you will do? You will do it by categorizing them. Okay. Example given: data into mean and unit variance and estimates covariance matrix. So these are the dimensional reduction technique we have seen in the last slide. The identification of principal components is performed on reduced features, not on the whole population. So here we are trying to reduce principal component 1, principal component 2. We are trying to. So again, something a stage ahead of the SVM actually. The identification of principal component is performed on reduced feature computing the eigenvectors. Okay, I'll tell you what is the eigenvector. A matrix for variation in the data, because standard deviation can be some part, and finally locate the data and the proposed features. PCA, where PC1, PC2 indicate that the first and second principal component obtained from PCA. So this is one indication, this is another indication of PCA. The objective in PCA as in the step is dimensional reduction. We said that. And what is the dimensional reduction? From whatever dimension was there, now K is smaller. K is smaller than D. Reduction from D dimension to K dimension, first step. There are many approaches to feature extraction. However, the three we consider on the PHM are principal component analysis, linear discrimination analysis, and self-organizing maps. So these three are there. We are only discussing others. I would suggest you can read and enrich your knowledge. Okay, and if time permits, I'll discuss this also. But at present, it is not in the scope of the work. And the covariance metric is computed as like this. So this is a covariance matrix 1 by n. It is very simple. Transpose x, the variable, and the transpose of x, and its principal components are dealt. So n is the number of observation in the data set x. X are data point in the x, and x is transpose matrix. So in matrix operation, you would have seen you change the dimensionality, you change the matrix this thing x to y, y to x, and then you try to see what variation is taking place, and that will tell you with the category principal component 1 and principal component 2. So this week we can summarize that we have discussed AI and under that ML and deep learning. We have discussed statistical approach. Along with that, we have discussed statistical methods also for data processing, feature extraction, and optimization. And ANN training, probably this thing can be take away, that you can develop your own ANN if you have data with you, and then or you can take from generic source some data and try to see how well you can use this ANN. And so central figure was ANN over here, and generic application, so one simple example has been given, because domain specific studies cannot be given, so it should be it is something like for illustration. So week 3 will be systems approach, because we have been talking about system a lot. Now we'll dedicate one complete week for system understanding, modeling, analysis and all that. Thank you.